Hello everyone, welcome to Dinesh Tech Bytes. Today we are going to see how to do encryption at rest in Kubernetes. So this is the agenda for today. Quick context on Kubernetes data storage. Why do we need to do encryption of data at rest? Let's configure the encryption. Let's see what are the things that can go wrong, how to debug it and how to fix it. And let's see how to rotate these encryption keys for better security in long term and what is called external KMS provider, how to configure it, and while configuring these external KMS providers, what can go wrong, again, how to debug it and how to fix it. And let's see how to develop our own KMS provider. Let's start with the high level Kubernetes architecture. So we'll be having control planes and worker nodes where all our applications will be running in the worker nodes. In control plane, we'll be having multiple components, out of which our focus today is etcd or xcd. This is the only storage component in which all the metadata that are needed to run a particular Kubernetes cluster will get stored. Let's go ahead and create a Kubernetes cluster freshly and uh, let's inspect the data that is present in the etcd. Let's see whether it is encrypted or not. If not encrypted, let's see how to encrypt it. Again, let's inspect it and see if whatever encryption that we are doing is actually happening it or not. Yeah, I don't have any cluster now. So I'm asking Kind to create a cluster for me. Kind is like an Kubernetes in Docker. So if we have a Docker in our environment, we can create the whole Kubernetes cluster in a single Docker container. So it's creating, it will take less than a minute to create a cluster. It will have all these components like API server, scheduler, control manager, XCD to run a full Kubernetes cluster for our development environment. Now let's see if it is created. Yeah, it got created. Now, if I do the same kind config view, I can see that, okay, the Kubernetes cluster is running in this local host and things like that. If we see, it is saying it is port 36677. Let's see if what it is. It is actually a Docker image, which is listening in this port in which the whole Kubernetes cluster is running. Yeah, now if we do get clusters, I can get the new cluster that we got created now. Yeah, let's do the list of nodes we have. Let's do list of pods we have. Now we have list of pods in our kube system namespace. Our focus today is etcd. Yeah, let's try to create some secrets and see how it is getting stored in uh, Kubernetes. So uh, kubectl create secret. Yeah, I'm going to run this command. Kubectl create secret. It is of type generic. The secret name is secret1 in the default namespace. Key for my secret is my key and data is my secret data. Yeah, so we have created this secret. Now let's try to get this secret. Kubectl get secrets. Okay, I got the secret. Let me try to get the whole YAML file for the secret. Yeah, so we have the whatever the secret one we got created, and we have my key, and it looks there is some data transformation here for the value that we have given. If we see what is it, it is nothing but a base 64 encoded. So if we try to do base 64 decode, you will actually get the data, which means like yeah, we are able to view the data. Now let's see how the data is stored in the etcd. So for that, what we can do, like again, let's do kubectl get pods in the kube system namespace. Yeah, so we have this etcd pod running. Now we can exec into this etcd pod and run some native etcd commands to get the data from the etcd storage and see how this secret data is stored in the etcd. So for that, I have this command called kubectl exec into this etcd kind control plane pod, and I am saying run this command etcd API equal to 3 using the etcd CLI inside this pod. Uh, talk to the local etcd server running inside this pod, use the certificates present in the pods file system because etcd is running with the encryption, I mean the TLS enabled. So we have to give the proper CA certificate and the key to for the to talk to the etcd server. And we are saying give me the data for the key that is present for the default namespace secret1, which we just created. Now, if you print it, if you see, it is actually printing my secret. So which means if an attacker is able to get access to the etcd pod or etcd that is running in a node, if you're running etcd as a standalone process instead of running it as a pod, or if the attacker get access to the etcd backup that we are creating, they can easily inspect the data that is stored in the etcd and get the secrets that are stored in the Kubernetes cluster, and they can do a lot of things, which means all our application that is going to run is going to use secrets for its purpose. For example, either it's an API key, database username, password, all the things we are going to put into the ETC as a Kubernetes secret, and we are going to use in our application, which means any attacker who get access to the etcd storage or etcd pod can actually see all our API keys, database, password, username, everything they can see, and it is it's a very vulnerable point. So which means we have to encrypt the data at rest. So let's see how to do that. So in order to do that, if we see this diagram, API server is the only point of contact that is going to read data from etcd and write data into the etcd, which means if we instruct the API server before writing, encrypt and write, before, I mean, while reading, read the data and decrypt it. We can instruct the API server to do that, which means all the data that are going to store into the etcd will be in an encrypted format. So let's see how to configure API server to do this instruction. Yeah. Now let me go into the Docker container in which the whole Kubernetes cluster is running. So let's do docker exec into the 704 ID with the bash. Yeah, I'm into this etc Kubernetes. Let's check once that, okay, we have the Kubernetes cluster running, kubeconfig with the admin kubeconfig get nodes. Okay, we are able to access the Kubernetes cluster and the Kubernetes pods inside the Docker container. Okay, we are able to see everything now. Now we can instruct API server that is running here to encrypt the data. If we see in kind or in kubeadium based clusters, all these control plane components are going to run as a static pod. We can see what is static pod as a separate content. Now we have this folder called manifest where we can put any the pod.yaml or any deployment.yaml, we can, any manifest file basically we can put into this file, and the kubelet will watch for this file and will create the components, say that pod deployment, it will create it. Actually, it is a pod, it's a static pod. So you can only put pod.yaml and manifests, and kubelet will be able to create those pods in this particular node. So now if you see inside manifests kube API server, okay, I don't have the VA. Let me quickly install VA in this freshly created cluster. So I will do apt update. Apt install Vim. Yeah, so let's open this manifest file. If you see for the Kube API server, we are giving a lot of parameters like what is the address, what are the different certificates it should use. And we are also saying in order to talk to etcd, what are the certificates it should use, which means without these certificates, our API server cannot talk to etcd, which means between the API server and etcd, it is TLS. So man in the middle attack cannot happen. We are only concentrating on the data that is stored in the etcd to be encrypted. So now we are going to pass a flag to the API server to do this instruction. Let's see what is that flag. Yeah. So for the API server, we can say encryption provider config, and we can give a configuration file. And the sample configuration file will look like this. Okay. It is of kind encryption configuration. And I want to encrypt you can specify what kind of resource we want to encrypt. So we are saying we are currently concentrated only on secrets. So resources, secrets, and using this provider, the AES GEM, I mean the advanced encryption secret using this method and using this key, it will encrypt all the secrets that are coming into the API server and store into the XCD. Let's see how it is happening. Yeah, so let's create this config file in this location. So I'm going here. So let's create a directory. Let's see. Yeah, we have created this file. Let's paste this content. Okay. Okay. Now let's edit our API server with this configuration. Oh, ENC. Okay. So for API server, we can pass an extra flag from here. Okay. Yeah, but if you see here, we are saying, okay, from etc Kubernetes enc encryption config file. But this is Kubernetes server is running it as a pod, which means we have to make sure this file is inside this pod. So if you look into the list of volume mounts, we are mounting etc Kubernetes PKI, but we are not mounting that file. So let's mount that file. First, let's create the volume. So let's me copy this content and I pasted it. Let me call it as ENC. It is of type file. I am going to put ENC encryption config.yaml file. Now we have defined in volume, which means we have to define in volume mount also. So let me use the same format. I'll copy this. Let me paste. Mount path is Kubernetes, etc Kubernetes ENC encryption config.yaml. It is ENC. It's again read only because API service only going to read the contents from this file. Okay, let's save it. Let's see the list of the containers that are running in the control plane mission. In this case, it's a control plane Docker container, but it's a control plane, let's see, list of the containers running. Yeah, so we have these things running. API server is also running. We have edited it. Kubelet will watch for the edit and Kubelet will, okay, I have to create and add a new flag that Kubelet will update the pod. Yeah, if you see here, we are not able to see the API server here. So API server should be coming up. It's not coming up. Let's see if there is an error when we specify something. Yeah, it's running now. Yeah, it started running. But, yeah, now let's try to do kubectl get pods -a. Yeah, we are able to get the list of pods, but the API server is still not ready. Let's see the logs of it. Crickettle logs 36F. It looks there is no issue in the log. We have configured things correctly, which means here, yeah, it is ready now. Yeah, it will take some time for the readiness probe and liveness probe to check in and become it ready. So it's ready. Now let's get the list of secrets. Okay, things looks fine. Let's create a new secret. So kubectl create secret. This time let it be secret 2. Again, my secret data, let's create it. Okay, created successfully. Now let's try to inspect this newly created secret in the etcd storage. etcd storage. Now instead of secret 1, give me the data for the secret 2. Yeah, if you see here, we are not able to read the data at all. It is some encrypted format, which means if an attacker get the data of etcd, the backup data, or get access into the etcd pod, they cannot get the data because it is encrypted. Now, yeah, if you see here, it is showing the key. It is showing that, okay, it is using the encryption. This is the algorithm it is using, and it is using key 1 to encrypt. Yeah, this will use this metadata when it is trying to decrypt the key. Now let's try to get the data of secret 1, which we created before enabling this encryption. Now, if you see, it is not encrypted, right? Because only it will encrypt the secrets that are newly created. So now what we can do now, we can say kubectl get all the secrets in all the namespace and give me it as a JSON. Okay. Then we will say, again, we will write it to, so basically we are reading and writing kubectl replace all this data. Now, if you see, all these secrets are replaced. Now, if we try to see the content of secret 1, it is encrypted. Content of secret 2, encrypted. Even if we try to see the content of the secret that is present in the kube system namespace, it will be encrypted. Now, if you notice, yeah, now let's try to play around with this encryption config. Now, let me go ahead and open this configuration. Now let's see, when we enable this encryption, let's say, so basically we have encrypted all the things with this key. Let's say we want to disable it for testing purpose. So let me go ahead and comment these lines. Yeah, so I commented, right, let's have it, this as an identity, or even, or let's go ahead and manifest Kube API server. Let's say we are not giving this flag at all, right? Now let's say what will happen. Let's say somebody go ahead and remove the encryption, but we have all the secrets that are already encrypted, but somebody they don't want the encryption to happen, which means they'll go ahead and remove this encryption. Let's see what will happen. Again, yeah, we have edited the manifest file, which means kubelet should watch for the static parts and restart the API server. Let's see the status here. Yeah, API server is still running. Yeah, let's wait for API server to kubelet to quickly watch for the change and restart the API server. Yeah, if you see, so we have this API server trying to run, but if we see the logs of it, it is saying it is unable to read the secret, unable to unexpected list and watch error. It is unable to transform the key because we have encrypted and put into the etcd. Now we have disabled it, which means the API server doesn't know how to decrypt it because it is in an encrypted format, which means we cannot abruptly go and remove it. So let's enable it again. So manifests, not manifests. Yeah, manifests Kube API server. Let me go ahead and enable it first. Let's see. Yeah, it should bring up the new API server. And because we are using the same keys, it should be able to encrypt it and I mean decrypt it and show it to us, the users. Oh, but we have edited it here. So which means let's first enable it here. Yeah, looks the API server is up now. Now if we try to do the kubectl get secrets, okay, now the API server is back and it is working fine. Yeah, now let's try to rotate the keys. encryption. Let's see what is the key first. Encryption key. So we have this key. Uh, yeah, it is some random key. Secret is secure. Now let's try to rotate it. We are saying use this key. Let's get the key. Let's do a new secret key and let's base 64. Let's encode it. Let's get this key. Okay, we got this key. Now let's save it. Yeah, we have saved this new encryption key. Now let's restart the API server because it is changed, but API server should get notified. So either we can, because it is not the thing, kubelet may not be able to know because we didn't change any content in the manifest fields, but we changed the content in the host path. So let's do cricketl ps and let's do cricketl stop. The API server is 08TA. This is the ID. Yeah, it is stop. If we see again, it should bring up because kubelet will know, okay, I should bring up that pod. It is not running. So it will bring up the new API server. Yeah, it is trying to bring up, but it is getting exited. Let's see why. Mm, okay, invalid or secret is not. Oh, okay, got 15, expected only 16. Mm, okay, let's see how to change it. Okay, it's a new problem for me. Let's try to figure out how to fix it. Yeah, maybe let me add another character here. Let's give this value. So not here in the envc encryption. Okay, we have given the new key with the characters. Let's see if it is able to pick it up. Cricketl ps-a. We should see. Yeah, we got the new API server. Okay. Yeah, it started running. Now, yeah, there was some length constraint which I didn't figure out before. So which means now if we try to do kubectl get secrets, we'll be able to get it. Now if we try to get the read the secret 2, it is still using the key 1. How about did we change the value here? VNC encryption. Okay, maybe let's change to key 2 here before we create any secrets. Let's restart Cricketl PS API server. So let's stop it so that we can identify whether it's key 1 or key 2. Yeah, basically API server is able to accept it even if we have the same key for the encryption config. But for our identification, let's change it. Now let's see. Let's wait for the. We have filled it, so it will come up with a new the key to encryption config. Let's see. Let's wait for the kubelet to bring up the API server. It looks it is still not kicked by the kubelet. So one quick hack we can do is basically move the content of kube API server from manifest to outside, so that kubelet will only see, okay, I have to bring up these 3 static pods, and it will not bring up this. Then after some time, if we again do move this Cube API server here to manifests, okay, there is a change in file. Kubelet will now get triggered forcefully, and it will create the Cube API server. Yeah, now if you see immediately when we change the folder, it got triggered now and it is running. Let's see if you're able to access it from here. Yeah, we're able to get the secrets. Now if we try to exec into the etcd and see the data for secret 2, it is still using the key 1 and it is encrypted. Let's try to create a new secret now. kubectl create secret. Again, it's a secret 3. Yeah. Now if we try to get the data for secret 3, yeah, it is. Now let's try to print the data. Yeah, if you see here, it is using the encryption and it is key 2. Yeah, if you're not able to read it, the key like this, from the encrypted content, we can do hex dump, and the hex dump will actually print the keys in this hex format. Yeah, if you see here, it is saying like it is using the encryption ASC GCM approach, and we are using key 2 for encryption. Now, let's say when we say rotate, but we actually didn't remove the old one. Now, if we go ahead and remove old one, let's see what kind of error the API server will throw. Let me go here. So basically, we have removed this old key, but we have some secrets that are encrypted with the key 1, which means if we try to save this encryption configuration, and let's re-trigger the, let's restart the Cube API server. So I'm trying to move the API server from the manifest, which means the kubelet will remove this Cube API server because it is not part of the static pods. Let's see, once the kubelet remove it, then let's move it back to that directory so that kubelet will be able to again bring it up. Yeah, it is taking some time to trigger it. So maybe I can do cricket stop 8 C8. Yeah, we don't have it. Now let me move the Cube API server YAML file into the manifests. Okay, now API, now the kubelet will watch for it and it should create the new Cube API server pod. Yeah, it's bringing up of the API server 509. Yeah, it is not able to transform it because we still have something with key 1. So which means whenever we want to rotate the keys, first we have to add the new key. Then first we have to add the new key as the top of it, so that any new new secrets that are created will get encrypted with the new key. But before we remove the old key, we have to make sure there are no secrets that are present with the old key. So let's go ahead and enable the old key once again, and let's make sure all the secrets are migrated from key 1 based encryption to key 2 based encryption. So I am enabling it now. Let's move the Cube API server back to this. Let's make sure that let's make sure that kubelet restarts this API server. Then let's migrate all the secrets that are encrypted with key 1 to key 2 based encryption. Then we can completely get rid of key 2. Yeah, so which means when we are rotating keys, it's a two-step process. First, create a new key, then migrate all the secrets that are created with old key to new key, then delete the old key. So it's a two-step process. So similarly, if you remember when we first started, we had some secrets without encryption. Now, which means this identity says try to, I mean, there are some secrets that are in an unencrypted format. Now, so what actually etc, I mean, what actually the API server will do, will always try to encrypt with this first provider, and will always try to decrypt with list of providers available. It will always try to decrypt with the list of providers available, which means we have some secrets with key 2, we have some secrets with key 1. API server will know, like, okay, I will try to decrypt with all the possible providers, but it will always encrypt with the first provider. So if you have any secrets that are not encrypted, you should provide identity. And if you are in the process of rotating keys, you should have the list of already existing key until all the secrets are migrated with the new encryption key. Now let's see if API server started in this meantime. Yeah, it's been running fine for 14 seconds. Now let's try to get it from our local machine. Yeah, we are able to get all the secrets. Let's quickly verify. Secret 3 is based on key 2, but secret 1 is based on or secret 2 is based on, okay, secret 2 is based on key 1. So let's move all the key 1 based encryption to key 2, very similar to what we have done before, like get all the secrets and replace it. So whenever we do replace, basically we are reading all the secrets and writing it back. So while reading, it will use all the keys to decrypt. While writing, it will use the first key to encrypt. In our case, it is key 2. So when we do this, done. Now, if we try to get the value of secret 2, yeah, if you see, it is key 2 based encryption, whether secret 1 key 2 based encryption. Everything is now key 2 based encryption. Yeah. Now let's see the agenda. Yeah. When we rotate encryption keys, order matters. Yeah. Now, if you want to disable the encryption completely, you can specify identity at the top of the first provider, and you can keep all the rest of the providers below and replace everything, and you can remove the whole encryption completely, which means when we encrypt, it is again, I mean, when we completely remove again this 2-step, adding identity as a first provider, replace all the secrets, all the resources that we are encrypting, then remove the encryption completely. Yeah. Thanks, everyone. In the next video, let's see what is external KMS. Because now if you see, we are storing all the encryption config in the node itself, which means any attacker who get access to this Kubernetes cluster node can get this secret keys. If they know what is this encryption key, with this encryption key and with the data, they'll be able to decrypt it. So in the next video, let's see about how to have an external KMS provider. Again, there, how to configure it, what can go wrong. And if you want to create our own KMS provider, how to do it. If you learned something in this video, please like this video. If you have any questions or suggestions, please add it in the comment. For more content, subscribe. Thank you.